My name is Johnny Shell. I'm with SGIA Technical Services. I'm here to talk about exploring current film positive and computer-to-screen technologies for screen printing. The technology platforms I'll cover include laser, inkjet, thermal image setter, a full-blown image setter, and then some of the newer computer-to-screen technologies. Before we get into the actual platforms, one of the things I often want to cover with everybody is the comparison metrics you want to consider when you're shopping around. First and foremost, obviously, is the maximum output size of the device. This has a direct relationship to your screen size, so you want to be sure to investigate that. Also, the resolution is very important. The higher the resolution, the better dot shape you'll get in halftone printing, and straighter lines and edges on things like letters. The imaging technology itself, there are a wide variety of technologies in use, and we'll go over those in just a moment. The density, if it's a masked system, meaning you're either using a film with a dark area, which represents the positive area of the image, and so that has to be at a proper density. Also, the transparent areas of the film have to have a certain transparency. And then finally, the cost, not only for the hardware, but also any software applications that you're going to be required to use, and then also the consumables, both ink and media. So laser is the first technology, and this is really kind of going by the wayside. Not many people are using it. Maximum output is about 13 by 25 inches. It's a toner-based system, much like a desktop laser printer. The toner is fused by heat to the media that's being printed. Laser printers often use what's called a vellum, which is a transparent paper. But because of the heat, the dimensional aspects of each sheet of paper can change as they run through the fixation unit. On tight registration jobs, that could be an issue. There are polyester-backed vellums that are a little more stable to the heat, but there still is some dimensional change just because of the heat involved. A PostScript driver is needed if you plan on doing any halftone printing. The resolution is really good at 2400 dpi. I mentioned the vellum. There are no chemicals to develop the film. It comes out much like you see there at the lower right. The density is not that great. It's actually at the lowest lowest end of the density scale screen printing requires, which is 3.5. The cost of these systems are anywhere from $2,000 to $4,000 in US. Next up is inkjet. It's a really popular platform that's come of age and is heavily used for not only startup shops, but medium-sized shops as well. It uses piezo inkjet head technology. Resolution is really good at 2880 by 1440. There are no chemicals. Very good density, 4.6 Dmax. And the transparency is at 0.07, which is really good as well. You're looking at about $2,000 plus the rip cost, which can be anywhere from $500 to $1,000 as well. Film comes in either sheets or rolls, and so you can pay anywhere from $50 up to $300. And then ink for a full set is between $600 and $800. The average piece of film is going to use approximately 30 to 50 cents of ink, depending on the coverage. The thing about inkjet with the density, each halftone dot is made up of several inkjet droplets, and so the edge definition of the dots can be somewhat rough, but also because it's a liquid ink technology, the droplets actually form what could be considered as a dome, and so on the outer edges there, indicated by the arrows, what is the density that is achieved there versus at the most dense part in the middle. Thermal image setters are really only offered by one company, Exile Technologies. These devices come in widths up to 54 inches. There are no chemicals. Really, the only consumable here is the actual film itself. The film is heat sensitive, and when it passes through the right head of the device, the head fires and turns the media black. Very good density between 4 and 5, and transparency density at 0.06. These systems run between $15,000 to $30,000. The film, depending on the width and the length, can be between $550 and $1,600. Again, that's based on width. The next up is the image setter, and this was heavily used in the offset industry many years ago, but as that industry is converted over to computer to screen technology, or computer to plate, technology, image setters have become readily available for the screen printing industry. They use a laser imaging technology, which literally laser etches or laser writes to a photosensitive film. The resolution is outstanding at 4,000 dpi. There are chemicals involved. Once the film is imaged in the image setter, it has to be run through a processor, which has a developer, a fixative, and then a rinse. So there's chemicals involved, there's maintenance involved with that separate piece of hardware. Some units may offer inline developing, but expect to pay a little more for those. These systems can be north of $20,000 US, but are if you require very fine resolution, it's certainly an option to look at. Now, computer to screen has really come on heavily in the past decade, and some of the factors to consider when looking at this technology are: what are you currently spending on film? What about the image quality with the current system you have? The exposure times. Some films can block light up to 10 to 15% of the light. So you can get faster exposure times with CTS systems in that regard. And then standard operating procedures and pre-press. I mentioned the film cost, but there's also the film storage cost and finding film and losing film and damaged film that you have to re-image. With a computer to screen system, all that is taken out of the equation because everything is stored on the computer. Exposures are very fast because there's not the film element. Registration is very good because of lack of distortion under vacuum with a lot of films. So a lot of things to consider with the computer to screen technology. Simply put, if you're doing over 150 screens a day, a computer to screen system is something you definitely want to look at to save you some time and money. The first computer to screen system is DLP, digital light processing. I think this technology was invented by Philips. Resolution is up to 2540 dpi, and literally this exposes the coated screen. There is no film. What shines down on the screen is actually the negative area of the film, and leaving other areas unexposed to be washed out during development. These systems start at about $70,000 depending on format and size. But as you can see, the imaging system just shines the light down and exposes the coated screen. And under loupe, you can see it's very nice resolution. Next up is a laser system, which is offered by CFAR, I believe. It uses a Class 3 laser, up to 2400 dpi. There are no chemicals with this system, no film, and much like the DLP system, it exposes a coated screen directly. These systems start at over 150,000 US. But very nice results can be obtained. This is a shot of a print made with a laser set of screens. And then probably the most popular computer to screen technology would fall in one of these two classes, either a wax-based system that uses a ink puck that is heated inside the imaging system, and then those wax droplets are jetted onto a coated screen. Or inkjet, which is just an aqueous-based, water-based ink. So that's something to consider. The wax-based systems, because of the heat involved, they tend to be less robust than a water-based system where there's no heating involved. The resolution of these devices is very good at 6 to 1200 dpi. There's no chemicals, there's no film. This is simply a masking system. So it just jets directly to a coated screen. These started north of 70,000. And so as a cost analysis, just for computer to screen, if you're doing screens used per day at 25, so that's 6,500 screens per year, you're spending roughly $1.50 per screen on film and about $4.20 per screen in labor costs. So your annual savings by going to a computer to screen system can add up rather quickly. And of course, as the number of screens go up per day, your annual savings increase as well. That's data provided by Lawson Screen, who did a comparison study on this and came up with this table. So a little bit about who SGIA is. We're the industry's nonprofit trade association, serving our printer members primarily. Our product really is information, be it technical, which I cover, business management, where's the industry moving, what products are people producing, what's the next technology platform folks are looking at, and environmental health and safety to make sure that you're properly equipped with the knowledge you need to be in a safe working environment, keep the environment safe, and keep everybody healthy. So really our main thrust is to foster growth in the industry, to keep it moving forward. So our SGIA Expo is in Atlanta, Georgia, coming up November 4th through the 6th, and hope to see you there. Any questions? This is my contact information. Should you have questions, I'd be happy to help you. Thank you.